Good morning, afternoon, or evening, ladies and gentlemen. Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to put all of the rational stuff together, and we're going to add and subtract rational expressions with unlike denominators. Very simple, because we already know how to recognize and find an LCD. An LCD. We already know how to, using the LCD, form equivalent fractions. And we already know how to add rational expressions with common denominators. So we're just putting it all together today. It's not that tough, so don't stress. I promise you, you're gonna breeze through this. Now, in order to add or subtract rational expressions, you must have common denominators. Remember that, okay? Now, a lot of times I will say this. People say, oh, but what if it's not the least common denominator? As long as it's a common denominator, after you're done with the problem, you're going to reduce it anyways. You're going to go ahead and simplify. So it will come out to the same answer regardless. So number one, rewrite each denominator in factored form. Nice and easy. We already know that step. That's easy, Mr. Morrow. Come on. Rewrite each denominator in factored form. You're boring us, Morrow. Let's go. Come on. 2. Ooh, big one. Find the LCD. You got this down too. Okay? So this isn't a problem. You know how to do this so far. Step 3, rewrite the equivalent rational expressions. Well, guess what? That's exactly what we learned yesterday, gentlemen. Using the LCD, okay, you're going to multiply the missing values or missing factors to both the numerator and the denominator, which again, we already know how to do. So far, we've learned absolutely nothing new. Well, that's great. I always like to start the day like that. Just a little review. Nothing new. And now the last thing, we're going to add or subtract the numerator and keep the same common denominator. Well, guess what, guys? Again, that's really nothing new at this point. The only thing that's different now, the only thing that's new now, is the fact that we're going to have to put it all together. Okay? But you're going to rewrite each denominator in factored form. You're going to find the LCD. You're going to rewrite the equivalent rational expressions using the LCD by multiplying the missing factors to both the numerator and denominator. And at the end, you're going to add or subtract the numerators only, and you're going to keep the same common denominator. And then, of course, I didn't write this down because I always assume it, but I shouldn't assume anything. Step 5 should be simplify. Okay? The final answer. Once you're done adding or subtracting that numerator, go ahead and simplify that rational expression, please. You have to. It's required. Okay? So, no time like the present. Let's go ahead and try this out, guys. Let's see what happens here. Okay, so I've got 3 over 4x squared plus 7 over 14x. All right, guys. What is the LCD? We know how to do this. 28, beautiful. Now remember, if you went higher than 28, like for example, let's say you went 56, that's fine, okay? It's not a big deal. You're just going to have to reduce it at the end. So 28, and then what about the variables? X squared, all right. So I want every single denominator to look like that. That's my goal. So my friends, what do I have to multiply to this fraction, to the numerator and denominator, to make it look like 28x squared? A 7, thank you. What do I need to multiply to this fraction to make it look like a, there you go, 2x. Excellent. And now let's convert them. So this is going to be 21, thank you. Now I'm going to show you a little trick, okay? Once you've already established what's going to make both of them equal, this is the beauty of adding. It's a little trick. You could do this over 28x squared plus 14x over 28 squared, 28x squared, and then add them. Or you could realize, hey, wait a second. I already have the common denominator, so This can just simply be 21 plus 14x over 28x squared. Does that make sense? They both have the same denominator, so go ahead and combine them. Did I lose anyone there when I did that? Okay. Now, as always, guys, let's go ahead and factor, and let's keep the x as the leading coefficient in standard form. So I'm going to factor out a 7, which is going to leave me with 2x plus 3 over 28x squared. And then finally, I have to reduce. So 7 goes into 7 one time, 7 goes into 28 4 times. So my final answer is going to be 2x plus 3 over 4x squared. Does that make sense, y'all? Yes, sir. Could I have taken out a 7 from everything in the beginning here? Yes, sir. I just wanted to show step by step why I was doing that. But yes, sir. Does that make sense? Cool beans. Okay, example 2. What's the LCD? Always write the LCD. That's it. X plus 3, x plus 2. What do I have to multiply to this to get the same LCD? That's right. I got to multiply the missing factor, guys. Bless you. What do I have to multiply to this fraction, to this rational expression? X plus 3. Very good. So, let's go ahead and multiply. I got to distribute that negative 1, so this is negative x minus 2. Now, please pay attention here. Please, 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 please. I'm going to do it in red. This negative is attached to that 3. So I'm really distributing a negative 3, so this becomes negative 3x minus 9. And all of it is over x plus 3 times x plus 2. Please take a second to focus and see what I did there. Please realize that that negative is attached to that 3. So I have to distribute a negative 3 to everything. Please be aware of that. And if you have any questions, please ask. So now we've got negative 4x minus 11, which I'm going to factor out a negative. So I've got negative times 4x plus 11 over x plus 3 times x plus 2. And that's my final answer. Does that make sense? Please be careful with those negatives, guys. Please, that's my big warning there, okay? Be careful. We're good? Okay. Let's continue then. Okay, here the LCD is not so evident. We're going to have to actually factor. So let's factor. This is going to be, what times what is positive 2? 1 I have to get is negative 3? Negative 2, negative 1. Thank you. So, what is the LCD here, my friends? X minus 1, because there's an x minus 1 in both of them, and an x minus 2. Done. You with me? Okay. I want to get common denominators. This one's done already. This one's done. We don't have to worry about anything. But what do I need to multiply to this guy over here? On x minus 2. Thank you. Excellent, gentlemen. Let's distribute. So I've got x squared minus 2x. There's a plus here, so we do not have to change the sign. Plus 2x minus 1 over x minus 2 times x minus 1. Let's go ahead and clean up the top. Yes, sir? There is no negative 2 here. What are you talking about? X minus 1. X times x is x squared. X times negative 2 is negative 2x. No worries. Thank you, son. Okay, so let's clean this up. We got a negative 2x and a positive 2x. They cancel. So I've got an x squared minus 1 left in the numerator over an x minus 2 and an x minus 1. Let's go ahead and factor and clean this up. X plus 1 times x minus 1 over x minus 2 times x minus 1. X minus 1's go bye-bye. My final answer is x plus 1 over x minus 2. Is this making sense? See how it's not that bad? It's just putting everything together today. But it's really not that bad at all. Okay. Example 4. They look like they're identical denominators, but they're not. So let's factor them out and find out what the LCD would be. This factors out to become x plus 5. And when I factor out an x from this guy over here, this factors out to be x times x minus 5. So, what's my LCD? An x plus 5, x minus 5. Excellent. That's my LCD. That's what I want everything to look like, right? So, what do I have to multiply to this first fraction to make it look like my LCD? What? On x minus 5. That's it. Now in the denominator, don't I have an x minus 5, an x, and an x plus 5? That's it. My LCD is complete. Now I get, on this side, what do I have to multiply by? On x plus 5. Okay, and there is a negative 1. Good job. So, let's first multiply this guy. This is x minus 5. Now, please remember, that negative is attached to that 1. So, this becomes negative x minus 5, because I have to distribute that negative x, over my LCD of x, x plus 5, x minus 5. The x's will cancel, so I have negative 10 over x times x squared minus 25 to make it look pretty. Does that make sense? It's ugly. It's a lot of work, a lot of focus. Got to be organized. Does that make sense? Sir, my brother. I don't understand what that means. No. This x and this x cancel, right? So I have negative 5 minus 5 is negative 10, correct? But I just went ahead and simplified this. Isn't that a difference of squares? So I just rewrote it as a difference of squares. I could have left the final answer like this. I could. But on an SAT, be prepared for both. Okay, because they're the same things right there. Just one is factored, one is not factored. Does that answer your question, my man? Thank you, sir. How are we doing here, boys? May we continue? All right, let's go. You know me, I like to work. Let's do this work. All right, what do I do? Come on, you tell me now. Okay, but before I find the LCD, I got to factor. Remember, guys. So x plus 2, x minus 2. Okay, so what's my LCD going to be, guys? X plus 2, x minus 2. Excellent, gentlemen. Do I need to multiply anything to this first fraction? Nah. Do I need to multiply anything here? On x minus 2. Very good. So remember, my denominator is already etched in stone. That's it. It's done. A lot of times people stress out, oh, but not the denominator. No, we already made the denominator. That's it. We made it at the LCD. It's shared now. The x, we did nothing. We had to multiply nothing to that. But I do have this, so 1 times x is plus x minus 2. So this comes out to be 2x minus 2 over x plus 2, x minus 2. I factor out a 2. I got x minus 1 over x plus 2, x minus 2. And that is my answer. Or I could go 2 times x minus 1 over x squared minus 4. Either one of these works. It depends on the SAT which format they give it to you. I won't care on my test. Either one is the same thing. I just want you to be aware of the fact that they could write it both ways. I don't want there to be any surprises ever for you guys. Does that make sense? May we continue? Promise? Okay. So, I can't factor anything from the first fraction, but I can factor an x out of here. What's my LCD, y'all? X times x minus 1. Very good. What do I need to multiply to this guy? On x. Do I need to multiply anything to this guy? No. Very good. So, I've got x squared plus x. Look. Negative and a negative. Excellent. Good job, guys. Plus 2 over x times x minus 1. Okay? This is unfactorable. What times what is 2, but when added together is 1? Nothing. Done. Bye-bye. Have a good day. This isn't that bad, is it? It's good the way we did it, right? The step-by-step building the process. Yeah, we got more. Okay. What do we do here? How do I factor this out, y'all? So where does that negative go? Thank you. So this is going to become a negative 1 over n minus 1. Please, guys, stop me right now if you don't see how I did that or why I did that. Yes, thank you. Correct, sir. What's happening here is I'm factoring out a negative 1, which I'm bringing up here. So it becomes negative 1 over n minus 1. Thank you so much, son. Thank you. Anytime you do that, whether it's in the first fraction or the second fraction, bring that negative up. Bring it up. And distribute it, okay? Here, there's nothing to distribute it to except for that 1. But if there was like a 1 plus x, you would distribute that negative to the 1 and the x. You feel me? Thank you, sir. Okay, so then down here, I've got plus 2n over n plus 1 and minus 1. Come on. All right, so what do I need to multiply this bad boy? On n plus 1. Yeah, LCD is n plus 1 and minus 1, yes. Sorry, I should have labeled that from the beginning. That was my bad. You should always do that. Sorry, son. Thank you. And it's n plus 1 and minus 1. Thank you. So I have my LCD. So, okay. Remember, I'm distributing this negative. So this is negative n minus 1 plus 2n, which is going to equal n minus 1 over n plus 1 times n minus 1, which I can cancel those out. So my final answer will be 1 over n plus 1. Sir. Are you sure, my man? Okay. Yes, sir. Thank you. How do I get this final answer here? The one up here? Okay. Thank you, son. I distributed this negative, so negative times n is negative n. Distribute that negative. Negative times a 1 is negative 1 plus 2n. So negative n plus 2n is an n. And then I have a negative 1. And then I cancel that out with that n minus 1. No, thank you, son. I appreciate that. Making sense, boys? Okay, let's continue. We're almost done. All right, let's factor. So I've got x times x minus 2. And here I've got a 2 times x minus 2. What's my LCD, gentlemen? Beautiful. 2x times an x minus 2. Now we're getting the hang of this. Excellent. Don't do like I did on the last problem. Always write down the LCD. Don't be foolish or lazy like I was. Always write down the LCD. It's going to help you, I promise. So, what do I need to multiply to this guy? A 2. Just a 2, guys. Right? Because I already have an x times x minus 2 here. Now, what do I need to multiply to this bad boy? Just an x. So, let's distribute. 2x plus 4. This is a negative, correct? So am I going to distribute an x or a negative x? So this is negative x squared minus 2x over 2x times x minus 2. The 2x and the negative 2x cancel. And look what I have. I have 4 minus x squared. So what do you think I'm going to factor out? A negative 1 giving me x squared minus 4 over 2x. Yep, it's going to be reduced now, factored out. Negative, good job, guys. X plus 2, x minus 2 over 2x, x minus 2. X minus 2's go bye-bye. My final answer is negative x plus 2 over 2x. That was intense, but that was fun. I know I have a weird sense of fun. But you know, like that game Candy Crush? You know, that's all that is, right? They make little polynomial functions for the little shapes and the colors. And when you match them up, they're just doing like systems of equations. And they're canceling each other out. It's not that simple, but that's the idea. It's all math. We're doing good? Okay, guys. Yeah, I think this is it. I think these are the last. Yeah, that's it. 2 more, okay? And then we got time to review. Now, of course, I gave you some doozies for these, but, you know, I wouldn't be me if I didn't give you tough ones. All right, the other one I can factor here is an m minus 2 and an m plus 2. So, my friends, what's my LCD? N minus 2, m plus 2. Very good. That came out a little sloppy. Okay. So, what do I have to multiply this bad boy? M plus 2. You know, I'm just going to put 1, but you know it's both top and bottom, right, guys? Okay, let me just do it just in case. Okay. And then to this guy, what am I going to multiply? On n minus 2. And to this guy, I have nothing to multiply because I already have the LCD there, right? So this is going to be 5n plus 10 plus 5n plus 10. No. Minus 10 minus 20. All of it over the LCD that we already created, that we already found, m plus 2. Oh my God, m plus 2. Sorry, guys. A lot of mistakes. 5n plus 5n is 10n. 10 and negative 10 bye-bye, minus 20 over n minus 2 times m plus 2. Factor out a 10. I got n minus 2 over n minus 2 times m plus 2. Cancel out the n minus 2's. I'm left with 10 over n plus 2. What do you think? See all of you working so diligently. It's nice. Awesome class today. Awesome class. Did I mess up? Yes, it would be. No, because I factor out a 10, Papa. Yeah, sorry. I factor out a 10, and that's why I was up for that n minus 2, my brother. Thank you, sir. You almost got me there. You almost got me there. That makes sense, y'all? All right. Let's do this last one, and then we'll do some practice problems. So there's only one to factor here, and that's x minus 2 and x minus 1. So what do I have to multiply this bad boy? On x minus 1 to both top and bottom. Okay, so now, when you have it like this, guys, don't try to be fancy. Rewrite it for yourself. Make it easy for yourself, okay? This is going to be an x minus 1 times an x plus 3. Remember, there's a negative here, so it's going to be minus 6x plus 7 over x minus 2, x minus 1. Sometimes it's good to organize it before you start multiplying. Yes, sir, you have a question. Thank you. Okay, his question was, why aren't you multiplying it, Moro? Because it was really nasty up there. It was really messy. So I went ahead and just made it a little neater for myself. I'm going to multiply it right now. X times x is x squared, plus 3x minus x, so that's plus 2x, minus 3 minus 6x plus 7, all over x minus 2, x minus 1. So I've got x squared minus 4x plus 4. Oh, this is a great one. X minus 2, x minus 1. In this particular one, you can factor the numerator. This numerator factors out to be x minus 2 times x minus 2 over x minus 2 times x minus 1. Cancel out the x minus 2's. My answer is x minus 2 times x minus 1. And that's it. Does that make sense, my brothers? All right. Thank you very much. Hope you learned a lot. Have a great day.